Hello class. Today we're going to go over how to calculate test statistics for a one sample t-test. Okay, so first we're actually going to start off with this first question here because we have to basically understand in symbolic form what we are trying to kind of calculate in terms of a claim and versus what is that claim in reference to a null hypothesis and an alternative hypothesis. Okay, so let's look at the claim. The claim of this problem is that the mean pulse rate of adult males is equal to 68.7. So for whatever reason, somebody's making the claim that adult males have a mean pulse rate equal to 68.7. So we have to kind of test this by collecting data and running a statistical test, and determining if that is indeed the case. Okay, so first express the original claim in symbolic form. So here we have three symbols. This symbol, looks like a U, is called mu, and it refers to the mean. P is for the p-value. This is part of kind of where we are able to infer things about our statistical test. And this sigma here refers to the standard deviation. Since our claim is about the mean, we're going to use mu. And now we have different operators here. We have not equal to, greater than, less than, or less than, greater than, and equal to. Okay, so the claim is that it is equal to 68.7. Whoops, that's not correct. That's correct. Good job. All right, now when we kind of establish what the claim is, we now have to identify the null and alternative hypothesis. And this is again in symbolic form. So again, we're going to be talking about the mean for each of these because that's what our claim is in reference to. The claim is reference to the mean. And it's usually always the mean. We don't usually make any claims about p-values or sigma, so you can always kind of default these to the mean, probably 99% of the time. Okay, now when we talk about H naught or H0, that is the null hypothesis. And then when we talk about the H sub 1, that is the alternative hypothesis. The H naught is always, or the null hypothesis is always saying that basically there is going to be no difference. So it's always going to be equal to, for the most part. For the H1, the alternative hypothesis, and since we're looking at equal to, we're going to look at, well, what is the alternative to it being equal to? We're going to say not equal to. And this is the one where this symbol can change a lot. It could be greater than 68.7, less than 68.7, and that's where we have to make sure that we're reading the question very carefully to understand if we should be using whichever symbol we're using correctly here. Now, what beats per minute? Same thing for each. Really only one thing should be changing between your null and your alternative hypothesis. You're basically just comparing these two things here. These should be the same, these should be the same. Next question. Okay, now we're actually going to get into calculating this. I have StatCrunch open here. You can, since you see here there is no option to open it. In the homeworks you can go just to StatCrunch and it'll open it up in a separate window. In the exams you can just open it through a separate window that you've already kind of pre-opened so that you don't have to have this window closed out. Look at the previous video I did on that. You can check it out there and it will help you through that. So again, the claim is the mean pulse rate of adult males is equal to 69 beats per minute. For a random sample of 159 adults, the mean pulse rate is 68.2 and the standard deviation is 10.9. Okay, I'm going to walk through this very slowly. So we're first going to go to stat, and you see we are going to now venture below calculator's summary stats. We're going to go now to t-stats. Okay, why a t-stat? Why not z-stat, proportional stats, any of these other stats? Because I have to really read the question and understand what kind of analysis am I going to be doing. Okay, when you only have one group and the mean of that group is not referencing to a population, or it's not referencing to a kind of average of 0, then we're going to be going to t-stats. okay? And when we're only focused on one sample, so you see here, this is just a sample. We're going to be going one sample, t-stats, because we're just comparing it to a claim that we've made. And we're going to say with summary. Okay, this window pops up. Now we're going to put in all of our information. The mean of our sample data is 68.2. The standard deviation, 10.9. The sample size, 159. Okay, and now if you remember from what we did previously when we were putting our hypothesis into symbolic form, this is where it's now asking us, well, what is your null hypothesis equal to? So you see these things stay the same, this stays the same, it's usually always equal, just like I said earlier, and our claim is that it's 69 beats per minute. Okay, and then this is where I have to be specific. Am I looking at equal to, lesser than, greater than? I'm going to go with equal to, okay, because that's what the claim is. It's talking about if it's equal to. What's the opposite of equal to? Not equal to, okay? And then I'm going to click compute. All right, here's my output. One sample t-summary hypothesis test. We only have one sample here. We're testing this sample against the claim that we've made about the 69 beats per minute. The value of the test statistic is, the test statistic in this output is the t-stat, okay? And so I'm going to read very carefully, round to 2 decimal places as needed, minus 0.93, I'm going to say, because we have that 5 there. Okay, and so this gives you at least an initial preview into exactly how to calculate that. Now if I go on a little bit further, okay, and the Sonoma significance level of alpha equals 0.05, what this means here, the significance level of alpha 0.05, is now I'm going to be looking at the p-value of my output, which we have here, and I want to see if it is less than 0.05. And basically what this is saying is that this was my reference point to say that if the statistical test I have done is actually fairly certain, and this is 0.05 means about 95% certain, that what I am testing here is in fact true. I can't say 100% if it is. I'm just trying to say that it seems to be close enough. And so I've set a significance level of 0.05. So if I get a p-value below 0.05, that means I have a greater than 95% chance that, or really it's really saying that I have a less than 5% chance that these two things are actually similar. Okay, and thus rejecting the null hypothesis. So let's walk through this fairly slowly. So the original claim, the mean pulse rate in beats per minute of a certain group of adults is 75 beats per minute. The hypothesis test in a p-value of 0.08, okay, that is greater than 0.05. State a conclusion about the null hypothesis. Reject the null or fail to reject the null. Choose the correct answer. So you have to really kind of think of this as a double negative here. When you say to reject something that is the null, that means that you're actually accepting the alternative. When you fail to reject the null, that means that you're accepting the null, okay? So fail to reject is basically a double negative here, even though that kind of seems to be the same thing here. How can you reject nothing versus how can you fail to reject nothing, okay? So let's walk through that one more time. Don't want you to be confused. Reject the null means that whatever our null hypothesis is, probably is not the case, so we're going to go with the alternative hypothesis, whatever that may be. Or fail to reject the null, we're not able to say that these things are not equal to one another, so we're going to keep the null hypothesis. So let's choose the correct answer. Fail to reject the null hypothesis because the v-value is less than or equal to alpha. Alpha is 0.05. This is greater than. That's not the case. We already know that if we are above alpha, then we are failing to reject the null. So saying to reject, that's not true. Reject here, also not true. Fail to reject the null because the p-value is greater than alpha. That one is true. Good job. Okay. Without using technical terms, state a final conclusion that addresses the original claim. Which of the following is the correct conclusion? There is sufficient evidence to warrant rejection of the claim. The mean pulse rate of the group of adults is 75 beats per minute. The mean pulse rate in beats per minute of the group of adult males is 75 beats per minute. There is no sufficient evidence to warrant rejection of the claim that the mean pulse rate of the group of adult males is 75 beats per minute. The mean pulse rate in beats per minute of the group of adult males is not 75 beats per minute. So this is a little difficult because we didn't really go through symbolic form, but if you remember from a previous questions, our null hypothesis is saying that the mean pulse rate of these adult males is 75 beats per minute. Okay, since we've already stated that we failed to reject a null, we're going to support that conclusion from our statistical test since it's a p-value of greater than our significance level, and we are going to accept the null, therefore fail to reject the null, in other words, and say that there is sufficient evidence to warrant rejection of the claim. So this isn't true. Rejection of the claim. This is also kind of here. I would probably go with this one. There's sufficient evidence to warrant rejection of the claim that the mean pulse rate of the group of adult males is not rejection of the claim. The mean pulse rate. I would probably go with this one. See, this is really difficult because even though there's no technical terms in here, there's a lot of jargon you have to kind of sift through. Oh, and I was wrong. Okay, let's really think about this. Because this is a lot of, there is not sufficient evidence to warrant rejection of the claim that the mean pulse rate, I think it's this one. Good, okay. All right, let's walk through that really quickly. Okay, there is not sufficient evidence to warrant rejection of the claim that the mean pulse rate of the group of adult males is 75 beats per minute. You can see how B and C are a little bit confusing because essentially they're saying the same thing, but this one just is a little bit longer. And it's trying to be a little bit more detailed. So when it says there's not sufficient evidence to warrant rejection of the claim, okay, failing to reject, this is the one that we're going with. We're basically looking for how this language is reflecting this kind of term here, that the mean pulse rate of the group of adult males, so it can't reject our null hypothesis that the adult male's mean beats per heart rate is 75. Okay, that's essentially what this is saying here, just in very long verbiage. I would probably, if I were writing this up, I would probably say it's a little bit differently, but what are you going to do? Okay, so we've gone over a few things. We've gone over how to express our hypotheses in symbolic form, how to calculate a one-sample t-test using summary data, and how to be able to best kind of describe the difference between rejecting the null hypothesis or failing to reject the null hypothesis, and what kind of language best matches that. Okay, I hope this was helpful. If you have any other tutorials you'd like me to go through, please reach out. Thanks for watching.